I'm Atsushi Mori from Japan, working for a Japan engineering consultant. First of all, I express my thanks to AIT and AIT Solutions. Thank you for inviting me today. My presentation is concerning a civil engineering solution for infrastructure in Japan. Actually, I focused on some unique experiences EJEC has done so far. This is the contents of my presentation. And you don't know EJEC, obviously. I just first of all quickly mention about EJEC. EJEC started business on 1st March 1955, so now 61 years old. EJEC is a consulting company for especially infrastructure planning, designing, surveying, and so on. Now our engineers number is nearly 700, and our offices are, I would say, everywhere in Japan, so our service area is covering almost whole Japan. EJEC is doing mainly this 9 technical fields you can see on the slide. And also recently EJEC has a 5 priority business field which need is increasing. I just quickly talk about EJEC professional works for infrastructure in Japan. We have been doing a lot of professional work on road and the transport field. If you look at left side, which which showed very large expressway interchange near Tokyo, and middle picture shows a big, very unique shaped bridge, and right one shows large station plaza, which is located in north part of Japan, Hokuriku Shinkansen. So we also have been doing a lot of professional work, rivers and port field. We have been doing or continuing international professional work as well for more than 50 years. And the map shows that our project which have done so far. So Africa and Asia as well. I want to talk about the engineering solution, especially for design. First one is the very unique and complex structure. The name of the bridge is the Otagawa Owashi Bridge, which is located in Hiroshima Prefecture. Oh, sorry. Yeah, I hope you know the shape of Japan. So Hiroshima is the south part of Japan, and we actually got the first prize of the international bridge competition for this bridge held in Hiroshima in 2009. The total length of this bridge is over 400 meters, and it was opened March 2014. The bridge is a six-span continuous steel and pressed concrete composite structure with two-span arch structure in the middle. And if you look carefully here, the bridge has a pedestrian deck along the main bridge from here to here. So characteristics of this bridge I will explain. The bridge employs a new complex structure composed of PC girder and a steel brace reef arch. Because of this unique shape of pedestrian deck, we carried out 3D model wind tunnel test to check the behavior of the pedestrian deck. We got the Japanese Society of Civil Engineer Tanaka Prize for this bridge in 2015. This picture shows a section of detail of this bridge. Left one shows the main bridge, which has a two-box girder. And unique structure is here. A single chord arch with steel brace reef here. And right picture shows the place of pedestrian deck. Actually, the pedestrian deck is changing place along with main bridge. The picture I will show you. And top left one is the pedestrian bridge running parallel to the main bridge. And bottom right one is the pedestrian bridge under the main bridge. If you walk on here, you can see the very nice view. So next topic is concerning for bridge under characteristic condition. The name of bridge is Irabu Ohashi Bridge, and this one was opened in January last year. And this Irabu Bridge is the Japanese longest toll-free bridge. The length of this bridge is 3.5 kilometers. The location of this bridge is in Okinawa Prefecture here. This is far from Tokyo, about 2,000 kilometers from Tokyo to this red circle point. And Irabu Bridge is located between two remote islands, Miyako Island and Irabu Island here. So, view from Miyako Island at top here pictures, and the view of bridge from Irabu Island at bottom one, and we call this bridge dragon-shaped bridge. The Irabu Bridge is separated into three parts. One is 32-span continuous PC box girder, and second one is 3-span continuous steel floorboard box girder, and last one is 14-span continuous PC box girder. And actually, this part of bridge EJEC designed, and the length is nearly 1 kilometer. We got the Japanese Society of Civil Engineering Tanaka Prize as well as the previous mentioned Otagawa Ohashi Bridge in 2015. Actually, to design, we put high design wind velocity more than 80 meter per sec. In Japan, normally we use it about 40 as a design wind velocity, so about twice as much as the normal design we used for this bridge. Because of very harsh salty environment, so we decided to use epoxy-coated reinforced bar to stand this very severe environment. To maintain this bridge's life service span will be more than 100 years, we used cable fiber composite cable, CFCC, used for crack prevention of the covering concrete of the bridge. Okay, next sample is concerning design for an important cultural property bridge. The name of bridge is Kiyosu Bridge, which is located in Tokyo. This bridge was opened in 1928, so 88 years old. I think it's a very old bridge. And this bridge is still on service. The length of this bridge is nearly 190 meters and width is 26.1 meters. The structure of this bridge is very unique because this is called a three-span self-anchor type chain suspension bridge. And this type of bridge exists only in Japan. Also, there are 4 pneumatic caisson type foundation here. Nearly 9 years ago, this kind of caisson type foundation was very rare. I think it was the first try in Japan. And because of this unique and very vulnerable bridge, it was registered as an important cultural property of Japan in 2007. The bridge was too old to satisfy the latest seismic design criteria in Japan. Therefore, we actually designed to resist large earthquake. I mean, retrofitting we have done. To that, we selected a unique design procedure to verify dynamic performance of the bridge more precisely under severe seismic action. Also, the bridge is required to keep serviceability up to over 200 years from now. It is very difficult. No one knows in 200 years. Because this is an important cultural property, people cannot easily replace the structural element of bridges. To verify the dynamic behavior of bridge, we use the three-dimensional nonlinear dynamic analysis. Now finally, we use a damper to resist or reduce the seismic energy getting into this bridge. Here, damper. There are 8 dampers at each side, so totally 16 dampers we designed to transmit the reaction force of dampers into steering girder. Here we installed reinforcing support member here. We call this octopus legs. So actually the number of legs is a little bit short. I will skip the next one. Okay. I just say that could you allow me to make a brief advertisement? This picture shows the introduction of EJEC seminar in EIT on 13th and 14th next month. We have a seminar collaboration with AIT and AIT Solution in AIT. The seminar name is a technical seminar on road transportation infrastructure for Asian integration. So, in this seminar, we introduce Japanese engineer solution on new construction planning and existing facility maintenance. Especially, we focused on the road, bridges, and tunnels. Also, we are trying to share the information of infrastructure development in Asian countries. We have some keynote speakers from Japan, AIT, and Asian countries. From Japan, Professor Sugimoto of Nagaoka University of Technology is talking about tunnel. Mr. Furuki of JICA will talk about road pavement, and Mr. Narisawa of Metropolitan Expressway will talk about bridge maintenance. Also, EJEC engineers will come to join this seminar and talk about bridge and road and tunnel things. In the seminar, we will mention the quick report on damage due to Kumamoto earthquakes. You may know last month we had a very sad phenomenon in Kyushu, Kumamoto earthquake. The earthquake is still continuing, and we expected other damage of many structures from now. So you are welcome to join EJEC seminar. So don't forget the date and place. So 13th and 14th June, and place is here, AIT. Thank you for your kind attention.